over C defined by this recording with vertices like 0, -1, 0, 0, 1 and 1, -1. So we need to apply the Stokes theorem and verify whether the Stokes theorem holds good for this given shape or given area. All right, so let's first draw the required curve on a given surface. Okay, so let's say this is the x-axis and this is the y-axis. So we need to mark the 4 points which correspond to the given shape. Okay, therefore this is marked as follows. Okay, so the first point is, say, at equal distance from the origin. So I'll assume the points to be these 4. So if you look at the points given, and we need to mark the same thing on this. So first point is 1, 0. So this is the point 1, 0. Let me call this as point A. Then let's say there is a point B denoted by 0, 1. Then we have another point, say point C. This is -1, 0. And followed by we have the point D. This is 0, -1. Okay, now we need to draw the lines connecting these points. So this is line number 1. Line number 2 connecting this, and line number 3 connecting this, and line number 4, sorry, and this is the line number 4, actually connects series. Okay, then so now on this given particular shape we need to apply the Green's theorem. So let's apply the Green's theorem now. So according to the Green's theorem, the equation for Green's theorem is like this. Oh, sorry, not Green's, Stokes theorem, my mistake. According to the Stokes theorem, this is integral over C, the vector f dot dr should be equal to the double integral over the given region R, its curl this is curl of the vector this is curl vector f dot, you can write a ds vector. Okay, so first we need to start from the basics. So let us say that we want to perform, right, the vector f, right? So vector f is nothing but, so integral over whatever we write, that itself should look like the vector f for us. So this means the vector f is equal to, this is x into y So this is from the given data itself, I should be able to write that. So this is xy into I cap plus this is xy square into j cap, right? And the dr vector, this can also be written as, right, we know that this is dx into I plus dy into j cap plus dz into k cap. All right, now this should be performed in such a way that, right, we can directly apply the integral over c, the vector f dot dr should be equal to, right, integral over c, this is xy dx plus this is xy square dy, say this is 1, right? But I know that from the Stokes theorem I can actually apply this right hand side to perform the required calculation. So only thing is that I can directly equate this with the right hand side of the Stokes theorem to calculate this. So right hand side says that first you calculate the curl value. So first we'll write that. Therefore, the curl of this vector f is nothing but this is del cross f vector. So del cross f vector should be calculated as I cap, j cap, k cap. Second row will be dou by dou x, dou by dou y, dou by dou z, followed by there is xy in the first column. This is the component of y cap. Then xy square is the second component. There is no z component along z axis. So we will make sure that this is equal to 0. So in the next step, now we are calculating this is equal to, let's write I cap into dou by dou y of 0 is 0, dou by dou z of xy square is also equal to 0, minus j cap into, it is dou by dou x of 0, which is 0, minus dou by dou z of xy, that is also 0, plus k cap into dou by dou x of xy square is y square, minus dou by dou y of xy is y, right? So the curl, that is del cross f vector, should be equal to, in this case this is y square minus x. Okay, so now this is very similar to what we can write here is, therefore the question which they had asked is this, that is double integral over the surface S, this is the curl f vector dot ds should be equal to, this is double integral, I still write over S itself, this is y square minus x into, let's write the equation for ds, right? If you remember, ds has to be written in the following fashion. So this is dy dz into I cap plus the next term is, this is dz dx into j cap plus this is dx dy into k cap. This is the multiplier, but we know that the y square minus x has a k component, so only k into k can work, others cannot work. So this is equal to, we can write now, I need to substitute this, but first let me write the term first, y square minus x, k cap into k cap is 1, then dx dy. So dx dy indicates that I'm supposed to write what are the ranges of x and y in the given figure. So we consider a figure which is just like this. So I just have to evaluate the x value. You can see that x value minimum is -1 and maximum is +1. Y value minimum is -1, maximum is +1. So in this case, the x and y limits are -1 to +1 because it's a perfect square. So let's go ahead and calculate. So now I'm going to put the limits in the same fashion. Okay, so let me perform the integration with respect to the y first. So I have to write the dy first, then I am supposed to write the dx. Please correct. So this is dy dx, indicating that x comes at the outside. This is the outer integral is for x -1 to 1. Inner integral is for y -1 to 1. Okay, so this is equal to integral for x being -1 to 1. Let's integrate the terms with respect to y. So y square becomes y cubed by 3 minus x integration with respect to y becomes xy. Right? I am supposed to substitute from -1 to 1 for y. Then put then the integration will happen with respect to x. Okay, so therefore this is equal to, I'm going to substitute -1 to 1 for x. So put the value of y as -1 first, right? I think I have the limits as -1 and +1, right? So okay, upper limit is 1, so let's put 1 here. This is 1 by 3 minus -1 by 3, so this is plus 1 by 3. This is when you put the value of y as 1 by 3, then minus x into 1 minus -1, that is 1 plus 1 into dx. So before doing the integration with respect to x, let's simplify this. So this first term becomes 2 by 3 minus 2x dx. So this is equal to, there is a 2 outside, -1 to 1. There is 1 there. 1 becomes x minus x becomes x squared by 2. Again the limits are -1 to +1. Okay, let me remove this integral sign because I directly have performed this integration. So this is 2 times 2 into, that is divided by 3. Okay, so this means now when we simplify this, this is there is a 2 by 3, 1 minus -1 is 1 plus 1 minus the 2 cancels, this is 1 minus 1. So anyway, this term has gone, it's 0. So 2 into 2 by 3 is 4 by 3. This is the required answer. Alright, then let's go to the next question. Verify Stokes theorem for the f equals to 2x minus y times I cap minus y z square times the j cap. Okay, let me correct. yz square times j cap minus y square z times k cap with the surface as surface area as the upper half surface of the sphere x square plus y square plus z square equal to 1, and C is its boundary. Okay, so first let's recall what we have to prove here. The integral over C, the given f vector dot dr is equal to double integral over the given surface, it's the curl f vector dot ds vector. All right, now to prove the left hand side, I need just the curve. So the curve becomes a circle because the top half surface is a sphere, but when you look at the sphere from the top, it looks like a circle for us. Okay, so the C is a circle, that is, there is no z in that, right? That is x square plus y square equal to okay, so radius is given here, so r square, right? That is 1. So comparing this, we get r is equal to 1, right? And there is no z, so z is equal to 0, right? Which also indicates that the dz is also equal to 0, right? So first let's write the r vector. R vector is nothing but this is x into I cap, y into j cap, z into k cap. So this implies the, now if I write the dr vector is dx I cap plus dy j cap plus dz k cap. First let us perform therefore the f dot dr is equal to, see the f is already given, that is 2x minus y into I cap, then we have minus yz square into dy, and the last term is minus y square z into the k cap. Okay, sorry, this is expected to be the j cap minus y square z into k cap. This is the first part, that is f vector dot, let's write the dr, that is dx I cap dy j cap dz k cap. So as a result, after the multiplication, we are going to get this. This is equal to 2x minus y times dx minus, this is yz square dy minus y square z dz. So this is the vector f dot dr. right? But we know that since z equal to 0 and the dz is also equal to 0, right? The vector f dot dr becomes equal to, this can be directly written as, so wherever z is there, it will not come, dz will also not come. So simply we can write 2x minus y times dx. All right, so this we hold on for the time being. Now in this we have to substitute, right? Since it is a circle, we shift from the Cartesian coordinate system into the polar coordinate system. So in a polar coordinate system, we can replace x as r cos theta, so that is 1 into cos theta. So this implies if you have anywhere a dx, that can be substituted as minus of sine theta d theta. Then we have y is equal to sine theta. So this implies if you have dy, you can write it as cos theta into d theta. Okay, then followed by, since there is no z, I don't have to write any z part here. I need to write what happens with the theta. So 0 less than or equal to theta less than or equal to 2 pi. This is the range. So this implies the integral. So we'll write the LHS now. This is the LHS, right? So this should be integral over the given scene. The vector f dot dr is equal to, perform. This is theta should be equal to 0 to 2 pi. Right, we have the function written as 2x minus y. So 2 times x is equal to cos theta minus y is sine theta. This is multiplied by dx. So dx is minus sine theta d theta. So this is now equals to integral theta is equal to 0 to 2 pi 2 cos theta into sine theta with a minus sign. So I can write the first term as minus 2 times sine theta into cos theta. Minus of minus is plus. This is sine square theta d theta. So in order to simplify the first term, let us use the sine 2 theta format. So this is equal to theta is 0 to 2 pi. This is minus of sine 2 theta plus, there is a sine square theta. Sine square theta is 1 minus cos 2 theta by 2. So this is half of 1 minus cos of 2 theta d theta. So let us simplify this further. So this is equals to, there is minus sine 2 theta. So integration is cos of 2 theta by 2 plus, there is half becomes theta by 2 minus cos 2 theta becomes sine of 2 theta by 2. There is already one existing 2 there, so this becomes 4. So substitute the values as 0 to 2 pi. Alright, so when we substitute, this is cos of 2 times 2 pi is cos 4 pi, right? Cos 4 pi is 1, so this is 1 by 2. So the second term plus theta is 2 pi. 2 pi by 2 will become a pi. Then sine 2 pi becomes a 0, so minus 0. Then when I put 0 over there, this is minus cos 0 is 1, so this is 1 by 2 plus 0, and sine 0 is also 0. So you can see that pi by 2 cancels. So the answer here is pi. This is the left hand side of the given equation of Stokes theorem. So in the next part, we have to perform the right hand side of the Stokes theorem, but we know that the right hand side of the Stokes theorem needs a curl. So the curl vector f is nothing but this is del cross f vector. So let's write the curl now. I j k dou by dou x dou by dou y dou by dou z. So this is 2x minus y minus yz square minus y squared z under this case. Okay, so now let's try to expand this. So this is equals to I cap into dou by dou y of z squared. So the dou by dou y of z square y square z is, it's a differentiation with respect to y. So this is minus 2yz minus dou by dou z of minus y square. So this is plus 2yz. Then minus j cap into dou by dou x of y square z is 0. Dou by dou z of 2x minus y is also 0. Then plus, there is a k cap into dou by dou x of this is 0. Then dou by dou y of this is plus 1. So the answer here, you can see it's getting cancelled. It's simply k cap. Okay, under this case, we want to write the ds vector as well, that is dy dz I cap plus this is dz dx j cap plus dx dy k cap. So this implies when I write the curl of vector f dot the ds, I can see that there is a k term and the k term, only they can be multiplied. So the result becomes equal to simply dx dy. So we can simply write this as dx into dy. So this is dx dy, right? So this implies double integral over the surface, given surface S, dx dy should be equal to, now we know that this is the surface area of a circle with unit radius, right? Dx dy is the integration of the surface over dx dy gives a value of the function as, right, pi into r square. So this is pi into 1 square, that is equal to pi. So pi is the value of the left hand RHS. Okay, so let me just write that. So this is the RHS. Now we can see that the left hand side is equal to the right hand side. So since that is the case, we have proved the Stokes theorem, right? So LHS equal to RHS hence proof. So we proved that particular property.